Tonight's talk is given by Dr. Ed Knell. It's entitled Paleoindian Land Use at Pluvial, Lake Mojave in California's Mojave Desert. Dr. Knell earned his master's from the University of Wyoming, his PhD from Washington State University, and is currently a professor of anthropology at Cal State University, Fullerton. His Great Basin research focuses on the Mojave Desert of California with a long-term research project around Pluvial Lake Mojave that has addressed lithic technology and technological organization strategies, land use, settlement patterns, lithic raw material conveyance, and past climate. Dr. Knell's research is published, among other places, in American Antiquity, Journal of Archaeological Science, Journal of Field Archaeology, Journal of California and Great Basin Anthropology, Paleoamerica, Plains Anthropologist, and a volume he co-edited titled Paleoindian Lifeways of the Cody Complex. Would you please all give a warm welcome to Dr. Ed Knell. It's all yours, Ed.
All right, thank you. Do I have the screen sharing capabilities? Let's see.
Yes, you should.
Okay, yep. All right. Beginning.
That's good. We've got thumbnails on the left.
All right, perfect.
And
all
that's
right, well,
thanks.
Well, thank you. So as you might have heard from some of the different places that I've published, I originally started off as a Great Plains archaeologist, and that's really what my training is in. My master's and PhD are both from the Great Plains, dealing with the same basic time period, Paleoindians. But since I moved to California and started at Fullerton, it started in 2008, I have switched my focus over to, again, keeping with the Paleoindian focus, to the Mojave Desert. There's in part why, because, well, it's wide open and there's a lot as far as research goes, and there's a lot to be done out there. So it's a real good place, and I'm real happy that I have the opportunity to work out there. I'd also like to thank you again. Some of you may have seen me in 2010 is when I first presented for PCAS. So again, when I was very first starting on this project, I moved a long ways from there, so you'll kind of maybe get a sense tonight. Not that you'll remember my talk from 2010, but anyway, it's a pleasure to be back and kind of show you this next phase of what I've been working on. And this is based on a paper that we just recently submitted to one of the archaeology journals. We're still waiting back for some feedback and hear if they'll publish it or not and all that kind of stuff. So anyway, I hope you enjoy it. I tried to keep it, simplify it and keep it easy enough to understand. Hopefully I've done my job with that. Anyway, to start. So Paleoindian land use at Pluvial Lake Mojave in California's Mojave Desert. So I'm the one getting the credit tonight. I'm the one who's talking about it, but this publication and this paper and presentation would not have been possible without my co-authors. Jan Taylor is one of my grad students. She worked on we'll be talking about the vegetation, what the paleo vegetation was like around Lake Mojave and some modeling associated with that. Matt Kirby, Dr. Kirby is one of my colleagues from CSU Fullerton, is a geologist, a paleolimnologist. So he is interested in learning about climate change through the study of lakes. He's used to working at wet lakes, not the dry lake variety that we have in front of me here. This is a soda lake in the foreground. And then also Al Garcia, who is a GIS specialist And he's done a lot of the GIS work, geographic information systems work, that is went into building and doing this research as well. So in any event, I'm getting the credit tonight, but they also deserve credit as well for sure. So as I mentioned, as we're talking before, basically what I am presenting is a model of land use and a model of land use, and also basically a preliminary test of that model. So I'm just going to move this around so I can see my notes here. So the model, to kind of keep it simple and to kind of get us acquainted to what I'll be talking about and how this model is structured, it begins with paleoclimate, right? What's the past climate? We know that climates change, right? We're dealing with, climate warming today. And we also know that at times in the past, there was, ice ages and everything in between that. So we know that climates change through time. And as climates change through time, there were times when it was hotter and drier and wetter and wetter and drier. I think there's some variations of that, but anyway, you get the idea. And what that causes with these paleoclimate changes have an effect on the amount of water in places. And there were times when the lakes that are dry today were filled up with water, like the Pluvial Lake Mojave. We'll talk about that. But also, even within that, there were changes in the amount of water. There was fluctuating lake levels. And these fluctuating lake levels, and you can kind of get a sense in this figure on the left with the different colors on it, this is looking at different 500-year time slices. What that's showing is how the lake level at Lake Mojave changed, or Silver Lake, which is part of Lake Mojave, how that changed through time. And so we can kind of see that it did vary a bunch through time. So basically, paleoclimate is going to influence is going to result in the fluctuating lake levels. And these fluctuating lake levels are going to then impact the amount of wetland habitat. And so they were going to affect the extent of the wetland habitat. When we talk about the wetland habitat, we're talking about the amount of flora and fauna, plants and animals. And together, when we think about that, the amount of wetland habitat there is will really influence the patch productivity. How productive, how much food is available at that resource patch. In this case, Lake Mojave, and really more specifically, we've modeled Silver Lake, which again is part of Lake Mojave. So the paleoclimate is going to influence the amount of wetland habitat, which will influence the patch productivity, how much food is there, which then is going to influence people and their life ways, how they lived, how they did things. And I have a couple of things here. So for example, it's going to influence their subsistence strategies, what they ate. So there would have been times, for example, when there was when they would have widened their diet breadth, gone for a wider range of plants and animals, and times when they would have narrowed their diet breadth and gone for only, for example, the larger animals. Okay, so this can affect the subsistence strategies. And as we're focused on here, this will also influence the land use strategies, where people were placing themselves on the landscape during what seasons, how long they were staying, where they were coming from, how they were interacting with the landscape, etc. So that's the model in general. The paleoclimate is going to influence the amount of wetland habitat, the patch productivity, which is then going to influence land use strategies. So hopefully you're with me so far. Oops. Let's see. Okay. Now, moving on to get a little more specific here. So this is a map showing the number of pluvial lakes in the Mojave Desert. You can see Lake Mojave there kind of on the far right, and Silver Lake and Soda Lake, as I mentioned before. Together, those made up, when they were both filled up, those made a Lake Mojave. Otherwise, those were playa lakes today. And so we understand what pluvial lakes are. Pluvial lakes are dry today, right? This is basically right along the I-15. You go right past it on the way to Las Vegas, dry as a bone, as you all know, as you've driven out there. But during the terminal Pleistocene and early Holocene, so really say 10, 12,000 years ago and before, the weather pattern was changed, it shifted, and these lakes were filled with water. Why did that happen? Well, it has to do with, if you look at the bottom left here of your screen, you will see this little band here, and this is basically showing the jet stream. And what happened was the jet stream was split because those glaciers during the last ice age, and covered most of Canada and the very northern part of the United States, where basically the glaciers were big enough that they actually split the jet stream. So instead of the jet stream kind of going across, more or less that pink kind of line around the United States-Canadian border, some of the jet stream moisture went really far up north into, way up into the Arctic, and other parts of the jet stream, the southern half we're interested in, went much lower, and that resulted in a lot of rain in places that are bone dry today: the American Southwest, Great Basin, Mojave Desert, parts of California, etc. Now, I'm focused on Lake Mojave, but that is just, and I've been working on there for a long time, but that is just one of many pluvial lakes. And you can see a number of these on here, some big ones: China Lake, Searles Lake, Lake Thompson on Edwards Air Force Base, and there's lots of other smaller ones around the place. What is resulting in these lakes, right, as I said before, it really has to do with climate change. And so again, the water level in these lakes fluctuated based upon the climate. Getting more specific here, dialing into Lake Mojave itself, which you can see on here. Again, when Lake Mojave was filled, Silver Lake and Soda Lake, that comprised terminal Pleistocene, early Holocene Lake Mojave. So again, 10,000, 12,000 and before. And in fact, Lake Mojave, dates suggest, was around as a lake from about 25,000 years ago to 8,000 years ago, thereabouts, and then became a playa lake by about 7,000, 8,000 years ago. And today they are playa lakes, the dry lakes that we see today. What caused these lakes to form? Well, really, in this case, because Lake Mojave is on the Mojave River. What really filled the lake was a discharge from the San Bernardino Mountains, right? The places that we know today have been snowed in for a week or plus, right? Up there, moisture as it melts, moisture ran down the Mojave River and filled Soda Lake first, and then Silver Lake eventually. What filled the lake was not so much like rain or monsoons or anything like that. It was really this discharge from along the Mojave River that caused the lake to fill up and then change over time. Silver Lake is the terminal basin. So basically the water flowed from Mojave River. The Mojave River basically ended in Silver Lake. At least, and although earlier in time, it did actually breach past Silver Lake and actually moved up farther north to Lake Manly and the Death Valley and whatnot, but that's not really our focus here. So anyway, just to, again, give you a bit of a clue as to where Lake Mojave is located. It's right near the town of Baker, right? If you've gone to Las Vegas on the I-15, you certainly driven past it, probably stopped there. There's a lot of fun things to do there. There's the Magri Cafe. It's always a good time. The world's tallest thermometer, also a fun thing, and the alien jerky. So again, those are a lot of good times to be had there when we have crews out there. Oh yeah, and the Dairy Queen's also a lifesaver out there during the summer, which is when we normally go out there. So a lot of good things there. I have been working I did field work around Lake Mojave for a whole bunch of years now, as I said. The last year we worked out there was 2017. I began in, I think 2009. And we worked out there 9 years. When I say we were out there 9 years straight, we were out there for about a 10-day field season, right when after school ends, commencement. So basically May into early June. So we spent about 90 days out there, and we worked on about 10 different survey areas, doing pedestrian survey, walking across the landscape, finding artifacts, recording them. I analyzed a whole bunch of what we found, etc. Overall, we basically surveyed about 13 square kilometers, or about 5 square miles of around Lake Mojave, and 8 different shoreline areas. That's where the old stuff's located, the Paleoindian stuff and more recent stuff too. And then also 2 non-shoreline areas, the Baker Quarry down here, and also the Soda Mountains. These are quarry areas where they were getting stone to make stone tools. I've published on this. One of my students did his master's thesis on the Baker Quarry. So those are available. That information is now out there as well. Because to understand the stone tools and the how people were using stone tools, you got to understand how things are coming from the quarry areas. That gives you a good sense of what you then might expect around the lake. So that's where we started. I analyzed in field 5,482 artifacts. The vast majority, as you can see, of those were chipstone, 5,456. So just a relative few pieces of groundstone and a few hammerstones. We analyzed in the field. In the lab, I've had the opportunity to study the Campbell collection. That Campbells were early collectors in the 1930s around Lake Mojave. They're pretty well known, and they collected a lot of great stuff from various pluvial lakes in the Mojave Desert and Great Basin. And then also the collection at Joshua Tree National Park, and I'm trying to get my hands on the collection at the Autry Museum. So we'll see if I can get that. And also Brainerd in the 1950s went out, and he collected, along with someone else, they collected a huge amount of artifacts out there. So I've also analyzed that collection as well, or most of it. So anyway, you can see a few of the Silver Lake points and a Lake Mojave point here. These were found by the Campbells. So starting to dial in here a little bit more and look at more specific things around Lake Mojave. Looking here at the shoreline and the beach ridges along the north end of Silver Lake. You can see here there is this profile. You can see in this profile here that there are 3 major shorelines. Shoreline A at 287 meters, shoreline B at 285.5. These are the Paleoindian shorelines. These are the terminal Pleistocene, early Holocene shorelines. And there's one below here at 283 meters. It's a minor shoreline. Also around this is the El Capitan Beach Ridge Complex on the very north end of Silver Lake. There are a number of beach ridges as well. And these are not very well dated, but something I haven't been able to demonstrate yet, but I'm pretty darn sure is the case. I think that when I look at the elevations, I think that folks are really living up here on these shorelines, these beach ridges, because you get it's above the water, a little bit of a high vantage point, and look across the lake. You're not going to get your toes wet in the water. And so I think this is where people were largely living and habitating around the lake, but that's something still that I'm looking at. And so one other thing just to kind of mention as we get going here, there's also the outlet channel, and you can see the area kind of in blue here. The outlet channel is basically what controlled the downriver flow. So when the water was above this channel, above this outlet channel, water was able to flow north from Silver Lake down to lakes farther north along the Mojave River, eventually working its way down to Lake Manly, Death Valley. But when it cut down enough, when the water level was below the outlet channel, then the water would obviously stay just in Lake Mojave itself. So that had an influence on the amount of water at the lake. It was also very important in the early discussions in the history of Lake Mojave between the Campbells and other folks in terms of the age of the site and the artifacts around there. Again, dialing a little bit more on shoreline chronology, Lake Mojave is traditionally thought to have been regressive throughout lake history. By regressive, we just mean that it's the lake level started high when there was more water early in time, and then it basically drained through time, went down, 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 more or less consistently. So from 27.3, so 27,300 years ago, to 16.85 to 13.25, water was frequently at the A shoreline, the really high shoreline at the 287. And then, and also during this time with all the water up there, it was basically eaten away at the sediments around the outlet channel, perhaps even in the bedrock there. And that was then down cutting as well, down to eventually the 285.5 meter or the B shoreline. And that's in fact where basically once that cut down, the water just got to that level at the B shoreline, because anything above that was just going to flow north. By 13.25, the B was reached more than the A shoreline, and people were possibly around at the very end of this. Now, I say that because, well, that's interesting, because people weren't really necessarily around when the water level was at the A shoreline or 287 meter shoreline. They were only there more recently. 13.25 is basically Clovis times. Between 13.25 and 9.6, you have episodic flooding down to the B shoreline, or to the B shoreline only, and definitely people were here at this time. So basically, people were mainly associated with when the water level was at the B shoreline, not higher. And after that time, the lakes became playa lakes. Okay, so let's forget all the details here. And basically these two things here that I said, the A and B shorelines were regularly above water and habitable during the terminal Pleistocene, early Holocene. Okay, and the C shoreline was generally below and frequently underwater during the terminal Pleistocene, early Holocene. So any archaeology on there probably would not have been, it was underwater, so people weren't living there. So people should mainly be at the A and B shorelines, in short. That's a traditional story. There is also an emerging story, something that Dr. Kirby, well, he's a geologist, but Dr. Kirby and I are kind of working on, where there's evidence that the water level was not regressing consistently down, that there was actually that the lake level was fluctuating considerably. And you can see that in this base, and this is based on some 30 radiocarbon dates from around Lake Mojave. And basically what you can see this, if you ignore the red lines and ignore with the red and the white squares here, you can see that if you follow just the black dots, you can see that the lake level, and here's elevation on the side, lake level is going down and going up and then coming back down real low and back and up and down. So basically what's happening is that it appears the water level was going up and down, was fluctuating much more than people have given credit to before. So that's the deal with that.
Dr. Knell, this is Stephen Dwyer. If I could cut in real quick. We're not seeing a slide showing red lines.
Oh, really?
We see you talking.
You see me talking. Yeah, let me try the stop share. Yeah, there's a yellow thing. Let me try it again. Let's see here. Oops. Screen share. Is that better?
Yes, research question at the top of the page.
Okay, you can see that now? Okay. Let me get to slideshow.
It looks like we missed slide number 7.
Slide 7, okay. Yeah, that was when I was talking about with basically the water level going up. So anyway, okay, that's fine. So what the important part to take away from this was that the water level was going, was basically high early and then dropped down. shorelines were habitable. That was the terminal Pleistocene, early Holocene ones, and below that they were not. And then there's a submerging pattern where the water level is, we believe the water level is fluctuating considerably, going back and forth through time. It wasn't consistently dropping in elevation. So let me get, there we go. Is it still floating around, or is it okay now?
Again, got the research question full screen.
Okay, great. So the research question is basically this. Was Paleoindian land use at Silver Lake characterized by high residential and interbasin mobility, or comparatively long stays at resource hotspots? So basically what I'm looking at here, where people come into Lake Mojave, and were they staying there for long periods of time, or were they moving through very, very quickly? And if they were basically moving through fast, it's this WTS strategy, a wetland transient strategy. People come in, they look around, and they quickly move out of the area. Or is it this wetland stable strategy where people are basically hanging out for longer periods of time around these resource hotspots? And so what are they doing? What are they doing with that? So basically, short, fast move through the area, or the WSS, wetland stable strategy, lots of plant foods, and they're basically staying in the area for a while. The research goals are to develop a land use model, and which I've talked about before, is talking about the productivity of the wetlands. And so basically looking at the productivity of the wetlands and how those influence land use. We need to build that part of the model. And then optimal foraging theory principles. Optimal foraging is basically people doing the optimal thing to increase their survivability. Okay, so it kind of gets into Darwinian theory and whatnot. So any event, so there's a couple of models based on that. And then we're going to test it at Silver Lake using some 13 Paleoindian sites there, and then 12 recent period sites. And that's how we're going to go about building and testing the model. So the basic model structure is as follows. So you got the paleoclimate, as we talked about. That's going to influence lake level curve, how much water is in the lake. And we're interested for the Paleoindian period in particular, between 14,000 and 9,000 years ago. That's the Paleoindian times. And we're going to break that up using those 500-year, using the 30 radiocarbon dates we have, and look at that in 500-year increments. Take those dates, basically divide them into different bins, different units. And so we'll be able to look at increments of 10 different time slices of 500 years. We know that lake level, as we talked about, lake level influences the amount of wetland habitat. So we're gonna then build the extent of potential wetland habitat, and that is going to vary by lake level and what time period we're at. And then also the wetland habitat just tells us how much wetlands was there, but we also want to look at what the productivity of those resources was. We'll look at the caloric abundance of those edible resources. How much food was actually available, and that too is going to vary by time, step, and season. And based upon how much food was there, that's going to influence the land use strategy. When there is a lot of food, you got high patch rank, a lot of food, that's when we'll get the wetland stable pattern. People are hanging out there for longer periods of time. Or when there is low patch rank, there's not a lot of food, that's the wetland transient strategy. People will move more quickly through the area. So building the model of the temporal control aspect of this, again, I've already kind of shown this before. This bottom one down here is looking at the raw 30 radiocarbon dates. Here we've grouped them into bins. These red lines are basically showing the standard deviations, so not going to worry about that. But what you can see here is the 500-year age bins. You can see the 500-year, the midpoint of those that we focus on, and you can see the elevations that the lake was at these different times. And you can see that the lake was going all the way from, starting off at 284 meters, and then it's basically coming down, and then it get by 12 to 11.5 or the 1175, it's at 286, and then it comes down, down, down again. As I said, the lake was fluctuating through time. It wasn't going in a straight down regressive sort of pattern. So now we're controlling for time and lake at high stand. Now, once we have that figured out, now we have time and where that lake was, now we can begin thinking about building the model about how much food was actually there. And so what we're looking at was the food abundance. And we can look at the amount of food that was available both seasonally and also yearly. These numbers in yellow here basically were calculated following this formula. And I'm not going to go through the details of the formula, but it's basically an abundance formula that's going to look at basically the density of plants or animals or for individuals per kilometer squared. It's going to look at the weight of the animals. It's going to look at their caloric yields, and then the coal rate, how much, or the rate at which a plant or animal can sustain crop loss, hunting, etc. You throw these numbers in, and this is what Jan, my student, she pulled up all these numbers for these 9 different floral resources and these different faunal resources to give us a sense of how much food, and these are all edible plants, and of course the animals, edible resources that people could have eaten out there, what the caloric returns were for this area. And of course, plants will be available and edible during different seasons. You'll have animals, yeah, they're always there, but you'll have more of them during certain times and other times. So we can also look at seasonal changes as well. So now kind of getting to the patch productivity part. So now we're going to look at the aerial extent of wetland habitat per kilometer squared. So it's one thing to know how much food was there, but we also need to know, well, how much, when we're saying per kilometer square, we need to know how much potential wetland was there. We used the GIS method to figure out this wetland habitat, called the Wetland Habitat Index, that basically characterizes the amount of potential wetland habitat, following something that Duke and King did. Anyway, long story short, what you do is, the idea is that plant resources were available, wetland habitat resources could develop in areas of less than 1.8 meters. So basically, for each of the high stand elevations, we basically figured out, well, how much of that lake area was less than 1.8 meters or less, and that told us how much area was potentially food resources were growing there. So the wetland habitat index is basically a simple formula: wetland habitat area, what's the area less than 1.8 meters, divided by the total lake area times 100, and you get the wetland habitat index. What you can see here is that the wetland habitat index at times was very high. Early in time, you can see this on the far right here. There were times when it was orange, when it was kind of at the medium level, and then times when it was really low. As we said, the amount of wetland habitat is going to influence what people did, and so and their land use. And so now we're beginning to track this, and you can see again on this one here, the WHI by time step. You're seeing it's going up and down and up and down, which will influence when people should have been there. So putting this together, you can see on this one here, we've plotted the different age bins by the amount of food that was there, and you can see that there were times around 1375 it was very high, 14 it was very high, 13 was very high, then it came down and then went back up and down, etc. And you can also see that spring and summer, the green and blue, those were the best seasons to be around Lake Mojave, and fall and winter are a bit lower. So putting this together, you can see that when the amount of wetland habitat was real high, around 14,000 years ago, we have said this would be the time when you get the wetland stable strategy. Lots of food resources, that these were good times to be around the lake. At 10.75, for example, it was very low. That was a wetland transient strategy. That's not a good time to be at the lake because there wasn't a lot of food. So people would come in, stay there for a little bit, and then move on. And you can, I'm not going to go into all the details here, but you can see how we kind of get a sense of how we were doing this. And we were also making differences between spring and summer, because as I said, spring and summer were better times to be there. And so that we're more likely to get more stable land use strategies. All right, so we have constructed what we think to be the ideal model. However, that's a scale that we should be trying to work at. However, this model is not testable as we constructed it, unfortunately, right? So 500-year time steps, how are we going to track 500-year periods of time from the surface archaeology? It's just not going to currently happen. Seasonality, how are we going to get seasonality from the surface sites? Again, it's just not currently going to happen. Notice I'm emphasizing the currently. So we're going to do a testing bait and switch. That's the Caradonna string here, right? So we're going to have to simplify the model and simplify our test of it so we can actually do it. But the model we just developed, that's what we think things should be tested at. So to simplify this, again, we're just going to simplify the temporal scheme, and we're going to look at Paleoindian versus recent times. The Paleoindian, that's the terminal Pleistocene, early Holocene. And then the recent time will be post-Middle Holocene. So after radiocarbon years, after 8,000 years ago, everything more recent. And that's going to be mostly late, although most of the record is probably going to be late prehistoric in the last couple thousand years. So really it's Paleoindian versus recent. And then we're going to have to focus on the patch productivity again, the wetland habitat index, but this time we're focusing on just key elevations rather than those that are tied into the 500-year bins. So this, I was pretty happy when I came up with this. This is looking at the simplified temporal controls. And these are your higher elevations. So this is your elevations. Here's the 285.5 meter of the B shoreline, the Paleoindian one. Same, the 287.2. These are the early ones. And if you look at that, all of the sites with the western stem points, the Lake Mojave and Silver Lake points, the Paleoindian archaeology, and the crescents are all in those higher elevations. Once you get down below this 285.5, now you're starting to get into the types of artifacts that are more closely associated with the more recent time periods. Now you're getting monos, metates, you're getting P for pottery, that's a late prehistoric sort of thing. You're getting metates, monos, you're going to get some late prehistoric projectile point types and preforms. These are all in the lower elevations. So we have a pretty good separation here in the higher elevations with the Paleoindians and lower elevations, the post-early Holocene. This is what people had pretty much always said. And again, this is based on 13 terminal Pleistocene early Holocene sites from around Lake Mojave and 12 that are Middle Holocene and more recent sites. Focus on patch productivity. There are 8 key elevations that we're focused on. Again, we're not tied into the temporal sequence from before. Now we're just looking at straight elevations. There are, and again, you'll see, but some of them are so important. The 287 meter, the A shoreline, the 285.5, the B shoreline. And then we start just going in 285, 284, and kind of on down from there. And when you look at this, when you look at the wetland habitat index, and all the people are blocking this from me, you can see that basically right at the 282, 283 meter shoreline, you get some really high numbers from 27 to 12.4. These are higher numbers. more wetland habitat. These are higher patch rank times. And then in the upper elevations, they're much lower in 6, 7 sort of range. And the patch rank was low. Remember we said with low patch rank, that's when folks should be moving quickly through the area. There's not a lot of food resources, the wetland transient strategy. So that's what we expect for Paleoindians. And during the recent times when it was much higher, that's when we expect folks to be hanging out for longer periods of time. And again, this ties in pretty well here. So to test this, we looked at a number of different archaeological variables. We looked at features, so midden, HARS, residential structure. Those will tell us about occupation span. In short, you should, as people spend a longer period of time at a site, they should you should see more of these types of features. And if they're not spending long there, then you should not, it's unlikely you would find them. So features, unlikely in the wetland transient because they're not there very long, more likely in the wetland stable. We looked at a number of chipstone variables. The more mobile groups, right, the wetland transient strategy, they should have a lot of bifaces, high biface to core ratio, right, because these are considered to be portable, flexible tools, things that you need if you're moving around. A lot of formal tools, these are multi-tools that tend to be more multifunctional. And because they're moving around a lot, they should have a lot more tools with more retouched edges. They're more heavily used and reused and whatnot. So that's what you should expect for this, and you can see this here. And likewise, or opposite of it, for the more sedentary groups, the wetland stable strategy, when you should have more cores because people are stockpiling for future use, more informal tools. Informal tools are just quickly used sort of tools. Again, you have the stone there, just use it quickly. There's plenty of it around, so why worry about it? And then you got less retouched edges because again, they're just using them really quick. So you kind of get these expectations that are developed here. In terms of features, there are no midden or structures, no midden, no structures that are in clear terminal Pleistocene, early Holocene, or Paleoindian context. So this suggests a wetland transient strategy. You do have many recent period features around Soda Lake. We're just focused on Silver Lake here, but around Soda Lake, there's in the southern end, there's a lot of more recent archaeology. So perhaps a wetland stable strategy. People are there perhaps a bit longer. The biface core ratio, again, as expected, are seeing the high number of bifaces in the early Paleoindian levels and many fewer in the recent. So this difference is significant. Statistically significant. So again, the wetland transient strategy, moving fast, for the Paleoindians, recent, moving slow, and informal tool ratio. You actually have the inverse of expectations here, where you have fewer informal tools than you do in the recent sites. However, this is not statistically significant, and also there are sample size issues, so we kind of just put a question mark by that. Number of retouched edges, there'll be between 1 and 4 retouched edges on a tool. We had to build the sample size up. We included recent period sites from Fort Irwin. There just wasn't enough data from Lake Mojave, Silver Lake, to do this analysis, so we added that in. And we're basically finding a statistically significant difference where, as expected, Paleoindians, you have many fewer that have 1 edge used and lots with 3 and 4 edges used. Again, mobile groups can use these things more, wetland transient, and the recent, many more that are with 1 edge used and many fewer with the 3 to 4 edges used. That's the WSS. So to summarize, with the features, these are the land use interpretations. Pretty solidly, the Paleoindian, the wetland transient strategy come in. There's not a lot of resources, get in, get out, and which is what we expected, right? This was what the model suggested. During that time, there was not a lot of food. There wasn't the WHI was pretty low. And during the recent times, you have, it's all pretty much the WSS strategy. So the wetland stable strategy, people seem to be staying there around Lake Mojave for a bit longer than was the case during the wetland transient strategy with the Paleoindians. So does the simplified land use model work? Yes. Great. Clapping, congratulations all around. Right? When Lake Mojave was a little low rank patch, low productivity, Paleoindians optimally used the wetland transient strategy. They were highly residential, they were moving about, they were mobile, and they were moving quickly between different basins that may have had water or resources that they needed. This fits what generally is said about Paleoindians in Mojave Desert. So it fits what's the expected, the regional pattern. When patch rank is higher later in time, the recent period groups move less frequently. This is the wetland stable strategy. Again, probably as expected, although I think there's a lot more variability in that 8,000 years of time that we've had to kind of lump together. So, but overall, from the test, what we could do, it works. Apologies for the very long thing. I just didn't know how else to say this. But other than just kind of lay it out here. So apologies for this being long, but anyway. So while we were happy with the result and we got the model to work, it didn't quite, it kind of leaves a little bit of a bad taste in our mouth. It's not quite what we were really hoping for. So this is what this is all basically saying. Our conclusion that Paleoindians at Silver Lake employed a wetland transient strategy during the terminal Pleistocene early Holocene fits the available evidence, but is a static interpretation that implies Paleoindians used just one land use strategy during the several thousand years terminal Pleistocene early Holocene. So, right, so we have this nice model all worked out that we're saying people should be at times throughout times using the wetland stable, wetland transient, should be going back and forth, it should be seasonally variable. But what do we say in the end? It was just like during this several thousand years terminal Pleistocene, early Holocene, all we said is, yep, Paleoindians were using the wetland transient strategy. The more detailed but currently untestable version of the land use model clearly shows why this is an issue. Pluvial lakes were dynamic bodies of water whose lake level fluctuated through time and directly influenced the extent of and caloric returns from the available wetland habitat. Our model shows that Paleoindians at Silver Lake optimally switched between a WSS and WTS during some 500-year time steps and seasons. Instead, our conclusion conforms to the one land use strategy fits all time approach, the whole Western stem tradition, which lasts for 4,000 or 5,000 years, the early Holocene, which lasts for 3,000 or 4,000 years, and our conclusion is no different from what most people have said. Probably because they have the same issues we do. They can't pull apart time better and seasonality and stuff. But it's sort of a problem. It was our dissatisfaction of the one land use strategy conclusion that prompted us to create the more detailed land use model in the first place. Even though we knew obtaining high resolution temporal and seasonality data to test the model from desert surface sites is and perhaps always will be problematic. Science does not advance, however, without attempts to push the boundaries in the hope that other researchers have or can acquire the necessary data, or that today's rapid advancements in technology will enable researchers to collect the types of high resolution data needed to implement our or similar land use models. So it's the situation where it's great, but we still weren't able to achieve what we want. But while that's the case, we still think this land use model is worthwhile because it is, hopefully, if people read it and think about it and like it, they'll hopefully say, how can we begin to do some of the things that we're beginning to talk about and really suggesting should be done to better understand land use. The one land use strategy fits all for thousands of years was not the case. Lakes were much more variable, and so that there should be a lot more variability than what we can really get at archaeologically. So what does this mean? right? So we're kind of left with great. They were basically moving fast during Paleoindian times and slow during later in time. Well, it would be, these interpretations would be a lot more meaningful if we knew and had more information. Where were they going, right? So I'm focused on Lake Mojave, but there's lots of other lakes out there. They weren't staying around Lake Mojave year round. Maybe a few weeks, maybe going and coming back to it. We don't really know these things, so it would be much more understandable if we looked other places. Does a model work elsewhere? Right? Does a model work, at other of these lakes? Are the upland zones different? Right? They have different resources in the upland zone. So how does that fit in? Better temporal controls would be good. Improved archaeological analyses. Those ratios I talked about, those are fine, but those are just a quick snapshot. Those are hard to get behaviors from those. So we need more detailed site-based analyses, which is my next task that I'll be looking at. And also geochemical analyses, looking at the sourcing of the stones and where people are coming from, the obsidians and the different fine-grained volcanic stones out there, to get a better sense of where folks are moving and how they're moving across the landscape. And by understanding doing the geochemical analyses, we can get a better sense of, again, direct movements across the landscape. So that's about all I have for you. A special thanks again for having me back. It's been a while, but I'm glad to be back with you again. The Beagle Archaeological Research Grant funded a bunch of this, and my contacts on the BLM land, Jim Shearer, now retired, and Dave Nichols on the National Park Service land, and Jim Wavy Mojave tribes. And thank you. I hope you enjoyed what I was talking about, and I will stop sharing and open it up to questions if anyone has any questions or anything.
Yes, I have one for you.
Sure.
What kind of population do you think that these lakes could support?
Gosh, that is a really good question. My guess would be pretty small overall, because I think my guess would be they would probably wipe out the resources in certain areas fairly quickly. And then they'd have to either move to other areas, or they would have to stay. Maybe there's a lot of archaeology around the north end of Silver Lake. So that was probably a pretty good area. There was a number of embayments there. So areas where they were kind of protected, where water came in a little bit protected. There might have been good areas where there was a lot more of the wetland, the marshes and stuff. But I think if they would use those resources relatively quickly, a few weeks, a month, something like that. I'm not really sure. And then they would either have to move to other parts of Lake Mojave or move to other lakes altogether. That's a good question. That is something I do want to play with that a little bit, but I don't have any specific ideas yet.
Have you found any fluted points out there?
Good question. There are some concave base points which aren't quite fluted, but there's at least one of those that we know of. Unsure the age of those, and there is apparently one Clovis point, very nice looking Clovis point that was found on the north end of Silver Lake, but there's just a bad picture of it. No one really seems to know where it is at this point. So Clovis, as we know, Clovis was around there for sure, but really it's heavily on the western stem points, Silver Lake and Lake Mojave points.
I have a question.
Sure. Hey, Leah.
Hi, how are you?
Good.
It's nice to see the research progress. I appreciate you giving a talk. Are you, it seems like you're still looking for source material, that's a step you're going to be, looking for where the materials are coming from, the lithic materials?
Yes.
Are you seeing the differentiation between the types of materials being used that are falling along the model that you developed here?
The answer is we haven't looked at it yet, in part because the sample of artifacts that have been sourced geochemically is pretty small. So we will. So in fact, we this morning, one of my students, I'm not sure if she's here or not, Alex, we were getting trained on you have to use kind of brand new PXRF. Portable X-ray fluorescence machine. And so Alex, for her thesis, will be going out to Lake Mojave this summer and zapping, my technical term for it, trying to get many different sources, many different artifacts as we can from out there. So we have not been able to there's not been enough to tie that into the model yet. But yeah, that we're heading that direction if we can.
Oh, I look forward to hearing the results.
Yeah, me too, and I'm sure Alex in particular, because it's her thesis. So, but
right.
Yeah.
All right. Well, thank you.
You're welcome.
Dr. Knell, you had one slide for the lakes, and it had something called the Borden site. What was that? Borden.
Yeah, the Borden site. Yeah, that's part of. I want to say not Little Lake. I can't remember which lake that is part of, but there's basically, I can't remember which lake it's part of, but there's a huge collection of artifacts, concave-based stem points and western stem points from out there that were collected by a guy named Borden. And so there's a little bit of literature on that. And so that's what that's representing. And probably the map we used, there was, for one of my publications, those western stem and Lake Mojave and Silver Lake points, we analyzed a whole bunch of those. We just threw that on that particular map.
I had a question for you. First, forgive me, I was getting settled in the beginning, so I didn't clearly get the definition of your data set, but from listening to the rest of it, sounds like it was lithics. Is that
yes? It is. It's heavy. It's yes. I'm a lithic analyst, and that's what I do. But also, just given the nature, because these are surface sites, that's really all that preserves out there. So use what you got.
So I was thinking, lake levels up and down. Is there any evidence for fish hooks, things like that? And then where are they? They're using this as a catchment for hunting. Where are they taking the food? Where's the their family units or whatever units they're in? Where are they eating that stuff?
Yeah,
and butchering it.
Good question. So I think what they're doing is, as far as where they're going, I mentioned, I'm not sure if you saw that slide or not. When you look at the northern shoreline of Silver Lake, there are a number of beach ridges, and I don't quite have the data to prove it yet, but my guess is that I just know that a lot of the archaeology we are finding was around the 290 meter contour. So you have the 287 meter, a lot of stuff there, and 285.5, but there's a little bit up higher. And I think they're basically hanging out, habitating a little bit higher up there. And that's where they were hanging out, right? A little higher elevation, a little better view of the area. You don't get your toes wet, and that sort of thing. So yeah, that's my thought. And again, I think I have the data now to demonstrate it, but I don't, but I haven't done it yet. Pretty close to it. As far as what they were eating though, no fish hooks, nothing like that, because again, that's not going to preserve. There are some Joan Schneider and some other folks talked about. There's a paper in California archaeologists, whatever, from the SCA. There are some rock alignments out there that are low down, and they make a pretty good argument, I thought, that they were probably catching a fairy shrimp, brine shrimp. And so that might have been something they were doing at least more recent in time. But there would have been to each other different fish in the lake, little guys and stuff. So yeah, they were clearly doing something, that we just don't have that evidence for it.
Right. Yeah, exactly. And I was thinking about all the gathering, because it's the hunters and the gatherers, but we don't have the evidence for the gathering. Yeah,
there's really not much groundstone. There's just a tiny bit in the Paleoindian levels. I just kind of ignored that for convenience. You do find a little bit of mildly used groundstone in some of the Paleoindian sites,
Interesting.
Yeah, and on Fort Irwin, and I just recently came across a couple examples of that around Lake Mojave, Silver Lake, that I wasn't. So it'd be nice to do some analysis on those, the groundstone. There's also some groundstone from lower elevation levels around Soda Lake, and it'd be nice to do some, pollen washes or some, something or another to see kind of what they were specifically eating and doing with those, but not been done yet.
Yeah. Thank you.
You're very welcome.
I don't want to hog all the questions, but different lake levels. The oldest would be the highest, right? The shoreline.
Yeah, although our evidence based on the radiocarbon dates suggests it is going up and down, but yeah, it is that is the oldest are the upper ones for sure.
You would think that the later population would be walking around those hills, seeing some of the older lithics laying there. Wouldn't you think they would pick those up and bring them down into an area that doesn't quite fit with that time frame?
Absolutely. So yeah, what you're talking about is a problem with surface archaeology and other things, other even buried stuff too. But is you have what are called palimpsest assemblages, where you have people, living and using the same areas and habit, so just because those upper shorelines 290 meter, 289, just because people were there early in time doesn't mean later people also went up there as well and added stuff to it. And that is a problem. But while there's certainly mixing that has gone on, I was very happy to see, again, as I showed in that one slide, that all the western stem points and the crescents, those are the time diagnostics for the Paleoindian. Those are all up high, and all of the time diagnostics for the more recent periods, the late prehistoric projectile points, the ceramics, those are all in lower elevation. So there does seem to be, at least there seems to be a pretty good lateral distribution, but undoubtedly there's been mixing going on. And that's something that we just, and most, I don't think it was just hard to deal with. You can't really deal with it, It's just the preponderance of the evidence is how archaeologists generally deal with that.
Are there any other questions? I think there's something, 3 in the chat. Do you see them?
Yeah. No, I think these are all, these are highs, and then, I think these are just announcements. So they're not specific questions.
I had actually posted something in the chat and removed it earlier because I just asked you at the end. So I was wondering regarding like Cronies East and Cronies West lakes, are they considered part of Mojave Lake at all, or are they kind of individualized?
Those are individual lakes, yeah. So those are part of, those are also on like Lake Mojave. Those are also on the Mojave River. But those were not used. Those were used really heavily recently in time. Yeah, there's a lot of really neat archaeology around, I forget which one it is. One of those, there's some really neat stuff that was found. But yeah, those were not used early. There's no evidence of early use of those lakes.
Yeah, it was. We actually did field school out there. So it was really exciting. It was mostly lithic based, a lot of chalcedony and quartz, what have you. But yeah, I remember those being kind of like overflows when, as you had mentioned earlier, the Soda and Silver Lakes reached a certain capacity that they kind of overflow there to the west and then start filling up those other 2 lower basins, like the Mojave Sink, I think they call them.
Yeah. So actually, those lakes would actually be filled first because the water, the Mojave River moves from south to north. So it's going to hit those cronies first, and then it would move on to Lake Mojave. And that's why my geologist loves Silver Lake from a geologic standpoint. It's the terminal basin, and that's what paleolimnologists, that's what they want. That's what they want their mud, as they call it. That's where they want their mud from. So that's part also why we work there as well. And also around Silver Lake, it's just the shorelines are much better established and more evident than Soda Lake. And also from the GIS perspective, for some reason, the what do you call it? The DEMs, the digital elevation model for Soda Lake, is just terrible. And we just can't really get around that, but it's good. It's fine for Silver Lake.
Great work. Thank you very much for clarifying that. I appreciate it. It gets kind of confusing understanding the route for the Mojave River in that area, because it kind of does a little bend and stuff, and So, well, thank you very much. That was
very welcome. You're very welcome.
I have one last question for you. Early on, you had a slide of 3 projectile points, and it looked like the material was either jasper or maybe petrified wood. Do you know what they were made out of and where that material came from?
So those were actually, I think those were all cherts, different cherts. And the answer is no, we don't really know where the cherts are coming from. So, which is unfortunate. So when people talk to geochemical analyses, obsidian works great. And, for that, and then also what are the fine grained volcanics, dulcite, dacite, rhyolite, I guess the type materials, basalt, etc. Those can be sourced. They're a little more difficult than obsidian. Obsidian's the easiest, but then currently the cherts cannot be sourced very easily. There's been some progress made on that in various areas, but the cherts, just the way they form does not lend itself very well to geochemical analysis. So unfortunately, so when I read some of my colleagues' stuff, who are working up in the Great Basin, like Jeff Smith, for example, he's got lots and lots of obsidian and lots of data to be able to look at migration or conveyance patterns and all this kind of stuff. There's very little out of like 5,000 artifacts I've analyzed. There's probably not more than like 30 obsidian pieces, that we found, and they're almost all tiny little, chips, flake fragments and such.
Does anybody else have a question? If not, I'm going to say thank you very much, Dr. Knell. I'm going to be sending you your certificate of appreciation.
Oh, thank you, Joe.
That should hopefully start filling up your appreciation wall of certificates. Next month, we will have James Sneed in person, the second in-person presentation we've had since the pandemic started. And hopefully everybody can make an effort to be there in person. So the title of his talk is Relic Hunters, Archaeology and the Public in the 19th Century America. So that should be interesting. And I thank everybody for joining us. I hope everybody has a safe ride home. And thank you again, Ed. I appreciate it.
You are very welcome. Thank you all for listening, and I appreciate it.
All right. Good night, everybody.
All right. Good night.
Thank you very much.
Yeah.
Good night, everybody.
Good night.
Good night.
Thank you very much. Good night.
You're welcome. Good night.
Good night.
Good night.
Good night.
Good night. Bye, everybody.